Now let's look at an example situation where we can use an interface maybe. So we have an employee class and we said that, for example, an employee is incurring some expense for an organization, and that expense of the employee is the earnings that the employee is earning, or the employee is being paid from the organization's accounts. And then there might be some other kinds of expenses that the organization implying the same people is incurring. If you remember from our chapter 3 from our earlier lectures, there was an example in the exercise of invoice, and the invoice was trying to calculate the total amount that is being paid to a vendor based on the items and the quantity of the items that are being purchased. Now it can be any item. Here in this example we are only concerned with the type of expense that is occurring in the organization. Now the organization might want to keep track of both of these kinds of expenses because they are happening from maybe the same account. The salaries of the employees are being deducted from the accounts of the organization, and whatever the purchases that the organization is making, the payments for those are also being deducted from the organization's accounts. One way of doing this was, and that is what we discussed in our lecture examples as well, that we can use inheritance and we can inherit the common details into the subclasses, and in those subclasses we can implement or maybe override the methods that we need. But here is a situation where an invoice has nothing in common with the employee. So the employee, the details of the employee has first name, last name, maybe a social security number, and then if we inherit this employee, we are using only one example over here. In our previous lecture, we saw that we can have a bunch of employees that can be the subclasses of our employee class. Now here we are returning the weekly salary of the employee. Although this is an expense, but this expense, apart from this expense, nothing is common between the invoice class and the employee class. So an inheritance relationship might not work over here. It won't be a good idea to use inheritance over here. What we can do is we can use the interfaces that we talked about in this lecture, and let's say we declare an interface. This is the syntax of the interface. Public interface, these are the two keywords. Payable is the name of our interface, and we have included a method get payment amount. Now this is a generic method. Previously we were using an earnings method for the employee that was calculating the earnings of the employee. Now we are using a generic method because we want to calculate the expenses or deductions from the accounts of the organization. So we have declared a get payment amount method. Now if you remember from the lecture, this method is abstract by default, and by that we mean that we whatever class that implements this interface will have to implement the all the methods of this interface. We have only used one method over here. We can have more than one methods, and all of those methods will need to be implemented. So if you go through these details, unlike classes, all interface members must be public. So this is implicitly public. That's why we haven't mentioned any public keyword with it. And interfaces must not specify any implementation. We are not specifying any implementation details over here, such as concrete method declarations and instance variables. So there is no implementation detail for this method over here. All methods declared in an interface are implicitly public. So it doesn't make any difference if we write a public keyword with a public keyword with it or if we don't. So it won't make any difference. Abstract methods. So this is by default an abstract. So it will not make any difference if we write the abstract keyword with it or if we remove this abstract keyword. This is an abstract method by default. This is an abstract method implicitly. And this is static and final. This method is public abstract static final double get payment amount method. That is the signature of this method. A class that does not implement all the methods of the interface is an abstract class and must be declared abstract. We talked about this in our lecture as well, that whenever a class implements an interface, it is bound to implement all the methods of that interface. If it does not, that means we will need to declare that class as abstract so that any of the subclass of that class then implements the methods of the interface. Implementing an interface is like signing a contract with the compiler that states, I will declare all the methods specified by the interface, or I will declare my class as abstract. This is from our lecture. If you remember that it is a class, the implementing an interface is bound to implement all the methods of the interface. An interface is often used in place of an abstract class when there is no default implementation to inherit. So if we are not going to implement a method, as we saw in our earnings method, we are not implementing the earnings method in the employee class and we are able to make that abstract, but there were other implementations as we can see in this class, and we want these implementations to be inherited by our subclasses. If we have a situation where we want nothing to be inherited and an implementation to be inherited, then we can declare all the methods as abstract in an interface. We can use an interface and then the implementation will be provided by the classes implementing that interface. Now this is the syntax of implementing an interface. This is the name of our interface and we use the implements keyword. So any class that implements the interface will write it like public class implements the name of the interface. This class is abstract, so if we do not implement the get payment amount method in the employee class, we will not get a compilation error. If we see we are not implementing the get payment amount method over here, this is our earnings method from our earlier example. We have commented it out, but we are not getting an error because we have declared this class as abstract. If we do not declare this class as abstract, what will happen is straight away we get a compilation error. Employee is not abstract and does not override abstract method get payment amount in payable. Now it is bound to implement the get payment amount because it is implementing the payable method. So there are two ways to get out of this error. One is to implement the method in this class, and the other is to declare this class as abstract and pass on the burden to the subclass of the employee class. That in our case is, in this case, is the salaried employee. So the salaried employee extends the employee class. Now as long as we do not declare the get payment amount in this class, we will be getting a compilation error. So if we look over here, we are overriding a method that is the get payment amount method. Now in overriding we said that we can override a method from the superclass. Now there is no get payment amount method in the superclass. Again we can see that there is no get payment amount method in the superclass, but still we are able to override the method in its subclass, and that is coming from the interface. From the payable interface, the superclass is implementing the payable interface, and the method of that interface is overridden in the subclass. It is the get payment amount method. If we do not implement this method over here, straight away we should get an compilation error, as we can see, and the error is salaried employee is not abstract and does not override abstract method get payment amount in payable. So again, there are two ways to get out of this situation. One is to make this class as abstract, then we will need to create another class of as a subclass of this class, and that class will have to implement that method. Or we can implement the method over here, because we need to calculate the payment amount of this employee class, that is the salaried employee, and we need to return this the earnings of this employee. The earnings of this employee, the salaried employee, were simple. The salary, the weekly salary that this employee is getting. We can do the same in our example from our previous lecture. We can change the earnings method to the get payment amount method if we want to implement the payable interface in that example. The invoice class, again you will have the implementation from your previous maybe labs. If you implemented that example from the exercise of chapter 3, the invoice class has the constructor, the setGet methods, and it implements the payable. Now what happens over here is we are linking two completely different classes that we call the disparate classes, and voice class has nothing in common with the employee class, but we are able to use the same method in both of these classes. Or here, since voice class implements the payable interface, it is bound to implement the get payment amount that has been declared in the payable interface. Now again we are able to override the get payment amount method from the payable interface, and it will return the total payment amount that we are need to pay for the items that we have purchased based on the price per item. If we look at the main method for this class, we can use the interface to reference to the objects of our subclasses, or in this case we can say the classes that are implementing that interface. We can do it exactly the same way as we were doing with our superclass. In our previous lecture, what we did was we used our superclass reference to declare an array of objects, and we stored our objects within that array. So what we have done over here is we create an array of size 4, and we create 4 objects of the classes that are implementing that interface, and we store these objects as elements in this array. So the first element will have an object of the invoice class with the details. The second element will have an object of the invoice class with the details. The third element will have an object of the salaried employee class with the details. And the fourth element will have an object of the salaried employee class with the details. And we can print it the same way as we were doing with our superclass. We can use the enhanced for loop to print the details of this array. So we are going through the array one by one and we are printing the details of whatever the objects are there in the array. We can invoke the toString method even without writing it explicitly. If we print the object, in this case this variable of our interface, it should return the details of the class, the details of the object from our classes. And this will get us the payment amount. In the case of the employee, it should get us the earnings of that employee, and in case of the invoice, it should get us the total amount that we need to pay for the items that we have purchased. If we run this, we should look at the output. So it is quite similar to our example of polymorphism that we used in previous lecture, and where we used the abstract classes, an abstract class, and here we are using an interface. Implies and invoice is processed polymorphically. Invoice for the first object, the output that was an object of the invoice class. The second object was an object of the invoice class too, and we are getting these details from the interface array. The salaried employee first one and the salaried employee the second one, we are getting these details from the array. So this was one example where we can use an interface and we can link to disparate classes, completely different classes, if they need the same functionality. This concludes our lecture 17 over here. See you in the next lecture.